let's get started with the second workshop. So, agenda, we're going to go over the requirements first, and then we're going to move into workshop content. So, for requirements, you will need to have a basic understanding of coding, specifically object-oriented programming, classes, functions, conditionals, and variables. Since that's the kind of stuff we work with in scripting, mostly with C# and Unity. Second thing y'all are going to need is to have Unity already ready and the project ready to go. If you came to last week's workshop, you should have everything ready. If you did not, files are at this link, bit.ly/Unity Summer Files. We're going to have a couple more assets for today's workshop. So if you guys want to go to bit.ly/Unity Summer 1, it's the same link as last time, but now you're going to see a couple of folders. There's going to be a folder specifically titled number 2, collisions. And inside of that, there's going to be 2 image files that we're going to be using today to just mess around with the physics engine and also trigger colliders. So basic overview of today's workshop. I'm going to be first going over physics components and what needs to be added to a game object in order to have it interact with other physics component game objects. Moving on from there, we're going to start looking at actually enabling these collisions and playing around with them. And then from there, we're going to be moving on to trigger colliders. Essentially, there's a Boolean that turns a collider into a trigger collider. We'll be going over that in the Unity editor. And then we're going to be moving into trigger functions. So that's the way that we can manage these new form of colliders in order to programmatically start stuff or trigger stuff, hence the name, when these colliders are being used. And lastly, we're going to be looking at how to quit the game using these trigger functions and trigger colliders. All right, moving on to the workshop. Go ahead and make sure to download the assets from Unity Summer 1, the bit.ly link. It's just 2 PNG files that are going to be in the folder. Here we go. So the link should take you to this folder that's going to have a folder for last week's workshop with the files that we had last time, which was a couple of images and the Vaquero PNG, which is what we mostly used. Then going back to the main folder, we have the number 2 collisions folder, and there are going to be 2 PNGs, a box and a pickup PNG. So go ahead and download those, and we can go ahead and hop right back into the Unity Hub. So if you already have your project ready to go, mine's right here, the Character Controller 2023. Gonna go ahead and give it a click. Alrighty. So I'm right exactly where we left off from last time. Let me go ahead and close this animator tab. Move into my larger assets folder and bring in the assets that we downloaded just now. Here, just plop them in. So here's my box and my pickup asset, the images that we got. Since they're pixel art, we're going to have to go ahead and remove any filtering and compression. That's done automatically by Unity. Same thing we did last week with the Vaqueros image. So I went ahead and selected both of them to have the same effects apply to both of the images. So moving over here to the inspector, I'm going to go ahead and set the filter mode right here from bilinear to point. And down here in this section at the bottom, changing compression from normal quality to none. Then once you have those 2 changes, go ahead and hit the apply button so that the images get re-imported. And now that we have that done, if we go ahead and drag it into scene, we should see that the image is pixel perfect. Let me go ahead and delete that using the delete button. You probably noticed when I dragged the image directly into the scene window here, it automatically created a game object called pickup because the image is called pickup. And it automatically added a sprite render component with the image as the sprite. So that's just the way that Unity was able to understand what we wanted when dragging in our image. But yeah, let's go ahead and delete that. So zooming out right here, as I mentioned before, we're going to be looking at the components that we can add to game objects in order to start having them interact with the physics system of Unity. And at the base level, that starts with a rigid body 2D, which is what we used last time in order to feed velocity into the system in a way that would be manageable, and we wouldn't have to do any extra mathematics to be able to calculate the physics. So we have a rigid body 2D here, but we're missing a collider. So the rigid body 2D processes all the physics, but the collider is what defines the actual bounds of our current game object. It's the barrier that it uses to calculate whether or not it's hitting something, essentially a hitbox. And in game development at large, collision systems are a generalized topic that you can do further research into if you're interested in how the actual logic, processing, and mathematics behind collision systems work. So yeah, in order to enable the actual physics, we need a collider. So hopping in here to the Add Components button inside of our player game object, can go ahead and give Collider a search. And you'll have several different options here. We have boxes, capsules, circles, all kinds of different colliders. But for our purposes, we're going to want to be looking at adding a circle collider 2D to our main character here. So you'll notice that once we have the circle collider 2D added to our game object, a circle outline will appear here inside of the editor. Now that we have our circle collider, we want to go ahead and make sure that it's adjusted properly to work with the logic that we want the player to operate under. So in most top-down 2D games, the way that collisions work is that the collider is based in an area around the feet of the player. So for instance, let's see here if I can just quickly set this up. So for example, using this sprite just to quickly demonstrate this aspect, if you were to move your character around in a top-down game, and this circle is the collision that you're going to be using, once you hit the wall, which has a collider of its own, there's going to be this giant gap between where the feet of your player is understood to be by the player controlling the character and where the wall is. So normally in top-down, as I explained before, the colliders put a little lower, closer to the feet, so that when the player walks up to the wall, it makes more sense from the perspective that's being used. So all that's a long-winded way to just say that we're going to be changing the circle collider itself to a different size. And we're going to be moving it around to fit better with what we want as far as the player controller. And obviously, if you're not going for a top-down game, if you have a different sprite, different situation where you want collisions to be registered in a certain way, you can go ahead and use all the different kinds of colliders that are available in Unity pre-built for you to use out of the box, whether it be a capsule collider, box collider. But if you are working in a 2D space, make sure that it does have the 2D after the collider. But for the use case of this workshop, we're going to go ahead and use the circle collider 2D and bring down the radius a bit so that the collisions make a bit more sense to the player. So on average, when it comes to colliders, we want to make sure that the collider is a bit like a few pixels inside of the actual sprite. So whether that be an enemy, a bullet, the player, just to give the player some, room for error when it comes to playability. So for my use case, I'm going to go with a 0.25 radius for the circle. And it's a little bit high up on the character. Again, I want it closer to the feet. So down here inside of the circle collider where it says offset, I'm going to go into the Y and do -0.1. Okay, that's not enough. Oh, yeah, around there, -0.3. So the reason I chose Circle Collider was because we have a bit more of an ability to slide when it comes to the corners of the character. So if the character were to encounter a square, so say the edge of a house, the circle, when you're adding input, can slide around that corner. How would I visualize this? There we go. 2D sprites. Let's get a square in here. Name it square. It's good. Get the wall, replace it with the square. And let's also go ahead and grab a circle. Here we go, circle. So going back to what I was saying about a circle collider, when you're adding input here to the circle has the ability to keep sliding around and move past this edge, versus a square where you would be flat against this wall. And if you're adding input, it's going to keep you flat up until the very edge moves past. And then you start moving this way, or depending on the input, move that way. Yeah, no problem. Let me go ahead and, well, I'm going to keep the circle and square here just in case I need to use them for stuff. So now our player has everything it'll need to interact with physics. So now we can start having a bit of fun by adding things that are also physics objects into the game. Go ahead and grab this box sprite and just drag it into the game. And because it's so small, we're going to go ahead and do some scaling here. Let's see what 5 does. Yeah, 5 should be good. Make sure to have your scaling equal across all axes. Otherwise, if you ever apply mathematics to the scaling, it'll get a little funky. So now we have our box scaled up 5 times. As you can see here, it's a normal game object. So in order to make it a physics object, go ahead and add a rigid body 2D. And some of the adjustments that we're going to be doing here is going ahead and zeroing out the gravity scale so that it won't start falling in the y-axis. Since it's a top-down game, there's no real axis for falling. So we won't need gravity at this moment in time for the functionality we're going to be looking at. Because we're working with such small pixel-related things, I'm going to go ahead and bump up the actual mass of the object to around 5 and turn up linear drag and angular drag to 2. Let's see how that goes. So to explain a little bit about these variables that I went ahead and changed, mass is essentially the number used to calculate how much velocity the object will have when being interacted with by other physics objects. So also with gravity, if you add more mass, it scales, things like that. The linear drag is the amount of speed that it loses moving along the X and Y axes. So essentially you can think of it in a way as friction, although there is a way to process friction separately. But for our purposes, we're going to be using the linear drag. And angular drag is the amount of resistance that there is to movement angularly, movement in a circle, so spinning. The second part of making something act properly in the physics simulation that Unity has is the collider. So let's go ahead and add a collider to our box. For this case, I'm going to go ahead and use a box collider. Okay, let's see here. So for our size, I'm going to go ahead and drop it down a little bit. This comes back to, leaving a few pixels around the image so that people can have that buffer zone. 0.08, that might be too much. 0.1, let's go with 0.12. All right, so once you've added your box collider 2D and done the adjustments you want to it, you can go ahead and press play, and we should be seeing interaction between the box and the player once you move your player into the box, like so. There we go. So you should also be able to interact with your box the same way my character's interacting with it. So now that we have our box, go ahead and duplicate your box, move it out of the way, duplicate it again. just add enough boxes until you're satisfied. um, and since they're all enabled the same way with physics, you'll notice that when I crash a box into another box, they should interact with each other. And yeah, now I have a pretty decent physics simulation and just how to do some basic setup for these objects. And now we have, a fully working physics system for our 2D simulation. Now that we have how collisions work, let's go ahead and look at something that doesn't move. I'm going to go ahead and set up a wall. And this wall will have to interact with physics objects in the same way that everything else does. But we want other things to interact with its collider, but we don't want it to actually be moving or have the ability to move at all. So I'm going to go ahead, click on sample scene up here. Make sure to save. Click on sample scene up here. And I'm going to go ahead and add a new game object. I'm going to call it wall. And for this wall, all we're going to need is a sprite render so we can see where it is. And because we don't want it to actually move or anything, all we have to do is go ahead and add a box collider. Box collider 2D. So now I'm going to go ahead and grab that square sprite that I made earlier, just as a refresher as to how I got that square sprite in here in the first place. I right-clicked inside of the assets folder and went up to create the same way we did last week for making folders and making C# scripts. And I'm going to go ahead and hover over 2D, go to sprites, and then you should see the different kind of shapes here that you can make. For the example, let me go ahead and make another square. So now you have a sprite here in the shape of a square, and we have our wall. So go ahead and drag your sprite from the assets folder into your wall, sprite render. And let's see here. The collider usually automatically shapes itself to the size of the sprite inside of the game object. But because ours didn't, we can go ahead and click on this button right here inside of the box collider 2D to go ahead and edit the collider. So you'll see here, it's like somewhere in there. And looking back at the box collider 2D, you'll notice that the size is rather small. So let's go ahead and resize it to 1:1. And 1:1 seems to work almost exactly for the size that we're looking at. Right? So yeah, I just went ahead and changed the size in here to 1:1 after adding the square sprite and the sprite render for the wall. And now what we can do is we can go ahead and move to the inside of the scene window here. We can click on the move tool, drag the wall out, and scale it so that it actually does what we want it to do. So I'm gonna move it into the bounds of the camera a little bit. The camera is this gray rectangle here. So I want to be able to see it. And then I want to scale it in the X direction. Let's see here, 5, not enough. Let's go with 15. So I scaled it by 15 in the X axis in order to cover the entirety of the camera. So let's go ahead and hit play and see how that interacts with our boxes. So it's this white strip up here at the edge of the camera. And you'll notice if you try adding input for your character to move past the wall, it won't move past the wall. If you try slamming boxes against it, they hit the wall and stay there. But the wall doesn't move. And that's because we didn't add a rigid body 2D component to it. It's just the collider and these physics objects that we created that have the rigid body 2Ds and the box colliders inside of these boxes already are using their calculations and their logic to dictate the collisions between themselves and the wall. So that's pretty cool. So yeah, if you want an immovable wall, any bounds, any limitations, that's the way to go. Now that we've understood how to make a static collider that doesn't move and physics enabled colliders, we can move on to trigger colliders, which is a separate concept. So in order to start up with our trigger colliders, let's go ahead and drag this pickup image into our scene. So again, with the boxes, let's go ahead and scale this one up a bit. Let's go with 3. It's pretty good. And essentially what we want to happen here is we want it so that when the player gets a certain distance close to this potion looking pickup, we want the pickup to disappear and for something to happen inside of the code. Say we have a pickup variable inside of the player and we make it go up by 1 for every potion that he picks up. And obviously you can extrapolate your own logic based on that. So in order to get a trigger collider working, we need to go ahead and add our rigid body 2D. Remember to remove the gravity. The exact mass and drag and all this stuff won't exactly matter since the potion will be disappearing as soon as we get close to it. So once we have a rigid body 2D, go ahead and add a collider. So for the potion, since I want it to be like when the player gets within a certain radius of the potion, he picks it up. I'm going to go ahead and use a circle collider. And I think that radius looks okay for the size. I do want to move it down just a little bit though. That's too much, too little. I think that should work for all intents and purposes. All right. So I went ahead and just adjusted the circle collider. And in order to turn a collider into a trigger collider, what you need to do is go ahead and hit this check mark right here inside of the collider that says is trigger. So as soon as you do that, what happens is the collider, instead of detecting other collision shapes and reacting with them, it'll instead just detect and trigger whenever a collision shape is interacting with it. So it won't actually have a physics reaction. Instead, it'll send a signal that it's supposed to be having one. And for our use case, we can use this in all kinds of different situations. So we can use it to engage with dialogue. We can use it to set up areas where the player takes damage. Can use it to set spawners. All kinds of different things can be used with a trigger collider. The way that a trigger collider works is the actual trigger signal will be sent to whatever collider that it collides with. So if we were to move the player into the potions circle collider, the player is the one that receives the trigger signal, not the potion. So in order to process that trigger signal, we're going to have to go into the player's script and go ahead and look for that trigger signal. Since we're going to be looking for this trigger signal, let's go ahead and hop into the player controller's script. So the player controller is exactly as I left it last time. What we need to add to this script in order to start looking for this trigger signal is there's a set of built-in functions inside of Unity game objects. And those functions, there's a variety of them that can be used for different purposes. But for our purposes, we're going to be looking specifically at the built-in trigger functions. So there is on trigger enter. Make sure to get the 2D version of it. There we go. So there's on trigger enter, on trigger stay, and on trigger exit. So let's go ahead and just print to console so that we can see what each of these different ones do. So gonna go ahead and make the debug log enter whenever the trigger enter gets called. And for stay, have it log stay. And exit, have it log exit. This is just to better see what it does. But I'm going to go ahead and explain it beforehand anyways. So essentially, on trigger enter, that's whenever a trigger collider has entered this game objects collider. So as soon as they both interact with each other, this function gets called once. On trigger stay gets called every time that both of the colliders are overlapping each other. And on trigger exit gets called once when both of the colliders are no longer interacting. So in order to see this in action, let me go ahead and save the script, hop back into the Unity editor. And for the logging, we're going to be moving over to this tab, the console tab, to actually see the console logs whenever anything gets printed. So let's go ahead and hit play. And we should see once we interact with the pickups collider that enter gets called once, stay consistently keeps getting called, and then once I leave, exit will get called once. But yeah, so now that we have those working, the specific functionality that we are looking for is whenever the player enters this collider, we want the potion to disappear and some variable on the player to increment by a certain amount. So let's go ahead and head back to the script. So we won't need exit or stay since we will only care about the collider's first interaction with each other. The way that this works is the function returns to you the collider 2D of whatever collider you interacted with. It doesn't give you the actual game object back. So in order to get the game object, let me go ahead and set a game object variable called, I guess, object, and set it equal to this collision variable that gets returned back to us, dot game object. And that's how we would get access to this game object. Why am I getting an error? I think object is a protected word. So let me do, no, that's also going to be protected. I guess G object. There you go. So that one's not giving me errors. So this would be how we would get access to the actual game object of the collider that we're receiving from this function. But if we went around destroying everything that the player interacted with its collider, that would kind of not be exactly what we're looking for. We specifically want to get rid of potions whenever the player interacts with them. So let's hop back into the editor and make use of these tags that have been here. So for all game objects, you can tag them and set them to a certain layer, but we're going to be looking at tags right now. So a tag essentially is a way to just label different kinds of game objects. So say you had a bunch of different enemies and only enemies are supposed to receive damage from the player's attack, then you make it so that you check against the enemy tag. So you'll see here once I click on the drop down that there's a couple of default ones. There's a player one, main camera, game controller, but we want to add a tag specifically for pickups. So we're going to move down here to add tag, and it'll bring you here to this tags list. In order to add something to the tags list, we click the plus button, and here it'll ask us for a name. So I'm going to go ahead and type in pickup. It could be anything as long as it's something that you'll remember and then you can use for, generating new items for your game. But for our use case, go ahead and put pickup And once we go back to clicking on this pickup game object and move over to tags, you'll notice that from the dropdown, pickup has appeared at the bottom. So now we can go ahead and click it and add the pickup tag to our pickup game object. And now we can use this tag in order to check against all other game objects. And if it has this tag, then we destroy this item and we do something inside of the player script. Heading back to the script, now that we have the pickup tag on this game object that we want to remove from the game and use for all of our player logic, we can go ahead and check if it has a certain tag. So if gObject dot tag is equal to pickup, then we can do some logic. Right here, we're just checking the game object's tag variable, and we're checking if it's equal to the text that we're giving it. And that depends on the name that you give the tag that you have on your end. For mine, it would be pickup with a capital P. But now that we have checked that this object is in fact of a pickup tag type, we can move on to destroying this object. So there's a built-in Unity function for just wiping things from existence. It's called destroy. And all we have to do is feed it the object that we want destroyed inside of the function, and it'll take care of it. It'll just disappear. But we also want something to happen here inside of the player whenever we detect that there's an object and that we've picked it up. So for our scenario here, I'm going to go ahead and scroll back up. And right here, we have our public float for max speed. I'm going to add just a normal private float, not float, integer, so that we have whole numbers. So int to define an int variable. And I'm going to go ahead and call it pickups. And when the player script initializes with the player game object, I want it to be 0 for our use cases. So now that we have a variable that can track how many pickups we've picked up, we can go ahead and call the variable here and just increment it by 1, which is what the ++ does after the variable name. Let's go ahead and also make the pickups variable public. That way we can see it in the editor, and as our player picks up different potions, we can see this number go up right inside of the inspector. So now that we have this in place, we can go ahead and duplicate our pickup. So now I'm going to do Control D while selecting the game object inside of the hierarchy. Move this potion over here, Control D, drag it, Control D, drag it. So there are 5 potions in total. And if we go ahead and click on our player, you should see here under the player controller script that we now have the pickups variable available here for us to see it change. So now if we go ahead and press play, we'll have our movable boxes, our movable wall. And once we hit a pickup, it'll disappear and you'll see pickups increment by 1. Let me go ahead and collect them all. And there we go. We have 5 pickups. And from there, you can use this different logic with triggers, with collisions, to develop all different sorts of games and different play modes, situations, simulations. Later in the workshop, I do want to get into more specifics as far as actually changing stuff for the player when it comes to when you get a pickup, something actually happens. But yeah, you should have your pickups working. If not, let me know. And your pickup variable should be incrementing as well. All right. So moving on from here, we're going to make it so that once we've picked up all 5 potions, the game quits. So it exits out, you finish the game, you've done what you needed to do. So in order to do that, we head back to the script. So funnily enough, quitting the game isn't actually that difficult, which is, good for us. But, when I was first getting into game development, I always assumed ending the entire process was something that would be a bit difficult to do. But it's rather simple. So for our use case, we're going to go ahead and do a private function, private void specifically, because we're not going to be returning anything. We're just going to want this function to quit the game and be done. Going to go ahead and call it, going to go ahead and call it quit. And inside of here, we're going to call the application and its built-in quit function. So what this function does, it essentially kills the application when it's running. So let's go ahead and test it. So in the side of this pickup check, since we're already, detecting a collision with a trigger collider, we're already checking if it's of the tag pickup. So all we have to do here is add a check for if pickups is equal to 5. And if it is, we go ahead and call our new quit function. So that should be easy enough. Go ahead and save. Hop back into the editor. And if we press play, and go scoop up all the potions, nothing happens. And the reason for nothing happening in this specific scenario is because when we call application quit, we're trying to quit the active runtime, the build, the whole application. So in this case, if we were to actually, quit the application of the Unity editor, we would close the entire app, the entire editor screen here with all of our different windows. And that's not ideal. So that's not allowed. So instead, what we have to do is we have to go ahead and set the editor application's playing status to false. And let's hop back into the script. So in order to do that, let's go ahead and run a quick check. So first things first, we want to check if the Unity editor is indeed playing. So it should be Unity editor, editor application, and is playing. So that's a value that we can read. So if it is playing, we want to go ahead and set it so that it's not playing anymore. And to do that, we can go ahead and just directly set the variable to false. Oop. There we go. Autocomplete did its job. So if it is playing, we go ahead and set it to false. If the editor is not playing, that means that this code is running inside of the actual build. So if it's not running in the editor, it's running in an actual build runtime. And in that case, you can actually use application.quit. So with that check to see if the editor application is playing or not, and the different scenarios for whether or not we're doing it in the editor or in a final build of the game, this quit function now works in both scenarios. So if I go ahead and save, and then hop back into my Unity editor. Now when we get the 5 potions, I should hopefully have the editor stop playing. There we go. And just like that, the editor stopped playing. And since we've, checked for both use cases, if we were to build out this game right now and send it to someone, it would equate its own game application once you get all 5 of the potions because of the logic that we already added in for the quit function. And I believe that's pretty much all I wanted to go over today. Yeah, for today, I went a little short on time instead of going over. Okay. We have we still have a little bit under an hour left. Anything else you guys would want me to explore? Any questions not pertaining to this specific workshop and more, different kinds of Unity stuff? I could try to do some on the spot answering, see how it goes. Because I think that's all I wanted to go over for this section. I would have liked to include more status effects and stuff, but this was the scope of the workshop. Oh, okay. Yeah, that's a good point. All right. So for GitHub, let me go ahead and hop in to my browser. So let me go ahead and use my own link. Unity summer files. It's convenient that nobody's taken that bit.ly link yet. So right now it has the most recent version of the project as as the main branch. And when I go ahead and update this main branch to our current project, there's still going to be the branch with the player controller, the code for the player controller specific part that we did last week here untouched, so that if you wanted to go back and just check what we did up until that point, it's going to be in there. And I'm going to make a new branch for specifically this collision stuff. And GitHub is essentially a cloud-based repository storage. But if you wanted to just figure out how to download stuff from GitHub, I believe, let's see, you would need to go ahead and download Git first. Or you could also just, where is it? Yeah, you could download the zip right here. So if we go ahead and download the zip file, open it in our folder, cut and paste somewhere else, dev, game dev, Unity. And then if we can go ahead and make a new folder wherever you want to keep the project. Let's call this, I guess, Collider Workshop. And then I'm going to go ahead and drop the zip in here, extract everything inside of here into this folder that I made for it. Or not. And grab everything and put it in the main folder because I don't want it to do anything. Delete the zip in the folder that came with it. And from here, I have a folder called Collider Workshop. So all I need to do to open it would be to hop into Unity Hub. Go over here to open, add project from disk. I'm already in this folder, so I should have Collider Workshop here. And I can go ahead and add the project. So yeah, it's now here. If I go ahead and click on it, it should open up. Yeah, it's going to reinstall all the packages since those weren't saved, but that would be how you would grab it from GitHub. So if you don't have Git already installed on your system, you can go ahead and download the zip, extract it, and then navigate to that folder inside of Unity Hub, adding it from disk, and then just going to wherever you have it inside of your system. Yep, no problem. And if you do install Git, it's a little bit easier. You would just go ahead and copy this HTTP URL, and then go into your console, type in git clone, and then paste this URL. And then it'll automatically add a folder called Unity Summer 2023 and shove everything inside of it. I think that's still moving. All right. Well, if there's no more questions, that's it from me. This workshop's a lot shorter, so I should be able to edit it up and get it up faster, hopefully by Monday. If not, make sure to ping me and remind me, because I am busy with work most of the week, and have a midterm on Monday. It's going to be fun. Yeah, any questions, let me know. Hit me up on Discord. I'm around all the time when I'm not busy with work. Yeah, that should be it. And next week on Friday, we'll be looking at getting into, what was it? I believe enemies. Let me see here. Yep, we're going to get into enemies, health bars, hitboxes. So that should be pretty fun. All right. Bye, all. Appreciate you. And I'll see you next week.